Ever wondered how a particle can exist in multiple places at the same time? Welcome to the puzzling realm of quantum mechanics, a branch of physics that shatters our conventional understanding of the world. It's a domain where particles can be in two places at once, behave both as particles and waves, and change their behavior when observed. This strange nature of quantum mechanics is a stark departure from classical physics, where things are more predictable. Here we encounter a concept known as superposition. Imagine a particle that can exist in multiple states simultaneously, like being both here and there, or being both up and down. It's a bit like having your cake and eating it too, except in the quantum world, that's a standard affair. Quantum mechanics is full of such mind-boggling phenomena that challenge our everyday perceptions. In the quantum world, things aren't as straightforward as they seem in our everyday life. Have you ever tried to measure something, but the act of measuring it changes the thing you're trying to measure? Welcome to the Heisenberg uncertainty principle, a fundamental concept in quantum mechanics. Think of a particle, like an electron. You'd want to know two things about it: where it is and how fast it's moving, right? But here's the catch. The more precisely you measure one, the less precisely you can know the other. It's a bit like trying to catch a fast-moving hummingbird with a net. This isn't due to any flaws in our measuring tools, but rather a fundamental aspect of quantum particles themselves. This principle, while mind-boggling, is what makes the quantum world so fascinating and distinct from the classical world we're familiar with. This principle shows us the inherent fuzziness in nature at the tiniest scales. What if two particles, no matter how far apart, could instantly affect each other's state? This is the mind-bending concept at the heart of quantum entanglement. Imagine two particles born at the same moment and place, like identical twins. These particles are entangled, meaning their properties are intertwined. If you were to measure the state of one particle, you'd instantly know the state of the other, regardless of the distance between them. This instantaneous connection defies our everyday understanding of space and time. You might think of it like this: imagine a pair of dice. In the world as we know it, if you roll the dice in New York and your friend rolls the dice in Sydney, the outcomes are independent of each other. But in the quantum world of entangled particles, it's as if those dice are linked. No matter how far apart they are, they always show corresponding results. This isn't just theoretical. Scientists have proven quantum entanglement through experiments, observing this spooky action at a distance. It's a phenomenon that Albert Einstein famously struggled with, calling it spooky action at a distance. Quantum entanglement challenges our understanding of the universe. It suggests that at its most fundamental level, everything is interconnected in ways that transcend traditional boundaries. It's a concept that even the brightest minds grapple with. Quantum entanglement is one of the cornerstones of quantum mechanics, showing us the deep interconnectedness of the universe. You might be wondering, why should I care about quantum mechanics? Well, it's closer to your daily life than you might think. The principles of quantum mechanics aren't just theoretical musings, they are the backbone of many technologies we use today. Consider lasers, for instance. These aren't just for science fiction movies or fancy light shows, they're used in everything from supermarket barcode scanners to eye surgery. The lasing process, where light is amplified to create that concentrated beam, is a direct result of quantum mechanics at work. Then there's the humble semiconductor, the unsung hero of our digital age. These tiny devices control the flow of electricity in virtually all electronic devices, from your microwave to the Mars rover. And guess what? The way they function is all down to quantum mechanics. But let's not stop there. We're on the brink of a new technological revolution with quantum computing. While classical computers use bits, quantum computers use quantum bits or qubits. These qubits can exist in multiple states at once, thanks to the superposition principle, making quantum computers potentially millions of times more powerful than today's machines. So, next time you use your smartphone or computer, remember, you're taking advantage of the weird and wonderful world of quantum mechanics.